What's up guys, it's me Sir Ernest, and today we will solve example 5.1.1 of Fowles and Cassiday. The problem reads, a block of wood rests on a rough horizontal table. If the table is accelerated in a horizontal direction, under what conditions will the block slip? Okay, so let's first try to draw our problem. So for example, this is the tabletop. Okay, so this is your tabletop, and then on top of it is your block of wood. Okay, so as mentioned here, that the object or the tabletop is accelerated. So let's say that acceleration is towards this direction. So in order for this tabletop to obtain this acceleration, there must be a physical force that pushes this tabletop. Okay, so for example, if suppose we let mu s as the maximum or the coefficient of static friction, okay, between the table and the block. So the goal is this acceleration a naught must be as such that the inertial force associated with it, so that is your negative m a naught, must exceed the maximum friction between the block and the tabletop. Okay, so in other words, the magnitude of this inertial force, okay, must be greater than the maximum maximum static friction. Okay, so from your general physics class, this is equal to mu s times the normal force. So what is now the normal force? So that's easy to calculate. So at rest, the forces acting on the block will be as follows: the normal force and the gravitational force. And we know that for along the vertical, the sum of forces along y will be equal to Fn plus Fg, and this is equal to 0. So magnitude wise, this is now equal to Fn equals mg. Okay, so that means this is approximately equal to mg mu s. So therefore, if we're going to follow this, so the condition for slipping is that a naught, or the acceleration, must exceed mu s times g. Okay, so that means we must exert as much force as needed to overcome the frictional force. So because remember that in order for the block to slip, it must exceed your static friction. Okay, so the inertial force that is experienced by the block once the tabletop is accelerated is equal to this. Okay, so this inertial force that the block accelerates relative to the tabletop must exceed this frictional force. Okay, so this implies that you need to accelerate the table more for rougher surfaces than smooth surfaces. Okay, actually, if we're going to look at this, okay, this is actually the physics of the tablecloth cloth. The physics of the tablecloth trick, wherein you have a table that is covered with the tabletop, and then let's say you have a vase with flowers in it and other things. So the tablecloth trick is when you pull the tablecloth as fast as possible uh, to avoid this vase or anything on the tabletop to go with the tablecloth, because if this acceleration is not enough, the frictional force between, let's say, the vase and the tablecloth will prevent this vase from slipping. So because when this slips, so that means the tablecloth will move in this direction. So when you say slipping, this relative to the tablecloth, this will move in this direction. So the net effect is that this vase would remain here if this vase slips, okay, relative to the tablecloth. Okay, so that's it. That's a very simple calculations. So as I mentioned here, the acceleration of the tabletop must exceed the product of the maximum static, the product of the gravitational acceleration g and the coefficient of static friction. Okay, so that's it. So I hope you learned something today, and I'll see you guys in the next video. Bye bye.